Hello, everybody, and welcome back to Mr. Eichler's math class. I, of course, am Mr. Eichler, and this is Geometry PowerPoint number 3. Today we're going to talk about shapes. So I'm going to go up to the corner, and we're going to get this going. Our first term today is a vertex. Now, a vertex, as we learned in our last PowerPoint, is where two or more straight lines meet, such as this right here. Also, a vertex could be called a corner, because this line and this line are meeting in the corner. Coincidence? No, not at all. Our first group of shapes are known as the quadrilaterals. Quad meaning four, and lateral, line or side. In this case, there are many different kinds of quadrilaterals. All of them have certain things in common. Most importantly, quadrilaterals all have four sides. Our first quadrilateral is a parallelogram, and a parallelogram simply has two parallel pairs of lines. Boom, done. This is a rectangle. A rectangle also has two parallel pairs of lines, and it has four right angles. So a parallelogram kind of leans one way or the other, versus a rectangle, which has four right angles, making it a rectangle. It is worth noting that it has two longer lines and two shorter lines. A rectangle also fits the definition of a parallelogram because it has two sets of parallel lines. So a rectangle is a parallelogram, but a parallelogram is not a rectangle because it does not have four right angles. Our next shape is a square. Now, a square also has two pairs of parallel lines. It also has four right angles, and all four sides are of equal length. This is what makes it a square versus a rectangle. It is important also to know that a square fits the definition of both a rectangle and a parallelogram. Two pairs of parallel lines and four right angles. A square is a rectangle. A square is a parallelogram. A parallelogram is not a square. A rectangle is not a square. Only a square is a square. Our next shape is a rhombus. Now, this parallelogram has four equal sides, but does not have four right angles. It is a squared version of the parallelogram. All four sides the same length, but not right angles. Our next shape is a trapezoid. Now, this has only one pair of parallel sides. This shape is not a parallelogram. If you look here, these two sides, the top and the bottom, are parallel, but these two sides, the actual sides of the shape, are running to a point of intersection. And if we were to continue on these lines, they would intersect up here. An easy way to think of a trapezoid is this is what's left when you cut the top off of a triangle. Stay away from the guillotines, kids. Speaking of triangles, triangles! All right, triangles have three sides. And tri means three, and angle means angle, which is to say three angles. Boom. This triangle is our first one, and it is a right angle. It has one corner that will measure 90 degrees. And you can see that in this corner right here, it makes the corner that looks like a square. And that's what you're looking for when you identify the right triangle. Find the one corner that has the square in it. The square 90-degree angle, I should say. The next triangle up is an equilateral triangle. This is where all three sides of this triangle are the same length, and each corner must measure to exactly 60 degrees. This is what you would call your perfect triangle. All three sides same length, all three sides same angle. Our next triangle is the isosceles. This is the isosceles. I-S-O-S, sauce, C-E, cell, or C-E-L, cell, and then E-S-Es. Isosceles. That's an S-E-C, not a hard C. An S-E-C. Yes, it's an S-E-C. This triangle has only two sides that are the same length. Okay, this is your ice cream cone kind of triangle. If I turn this guy over and put a nice round sphere on top, boom, ice cream. Mint chocolate chip, please. Our next triangle is the scalene triangle. And each side on this triangle is a different length. Probably the more difficult to spot, and this is probably the easiest one that people will confuse with the right triangle. This one, not right. This, not right. But for some reason, this one in this corner tends to look like a right angle. It's not. And the way that you can tell is that with the scalene, the corner doesn't line up. This corner moves in on the longer line. Okay? And if I quickly flash back to my right triangle, I know I shouldn't do this, but I'm going to anyways, the two bottoms, the base, will line up in a straight line on the right triangle. Okay? As will these corners, they'll line up. And the lines look right, and these line up here, but not with our little friend the scalene. The sides don't line up. Okay, so just look for the tips to be off center. It's the easiest way to spot it. Our next triangle, the obtuse triangle. This simply means that one of our corners is going to measure greater than 60 degrees. And this is what happens to an equilateral triangle when you push down and go and you squish it down. Okay, we're going to increase the angle on this side, but we're going to shorten these two up. Okay, and of course, you can't have an obtuse without an acute triangle. And on this one, all corners must measure less than 90 degrees. Okay, this of course is a scalene triangle, which means also that an acute triangle can be a scalene triangle. Isn't geometry fun, boys and girls? Our next section is polygons. Hey, where's poly? Okay, I tried. A polygon is a closed figure made with straight lines with 3 or more sides. That is to say that the most familiar polygons, of course, are the triangle, the rectangle, and our little buddy, the square. But we can have all kinds of shapes so long as they have 3 or more sides that are polygons. Now, the only shape that doesn't fit in this category is a circle, because a circle only has one side. It goes all the way around, no corners, thus one side. A pentagon, a 5-sided figure. 1 side, 2 side, 3 side, 4 sides, 5 sides. Penta, meaning 5. A hexagon, hexa meaning 6, and 6 sides, 1, 2, 3, 4, 5, 6. And then, of course, an octagon, octa, like octopus, 8-sided shape. And that's it. I'm not going to bore you with the pop quiz because you don't have a classroom to look around to try to find all these shapes. So instead, I will end it here and say goodnight. Thank you all very much for watching, and we'll see you soon.